I work for this company, HashiCorp, which I'm sure you may have heard of. And that's me. I'm Nic Jackson, and I work as a developer advocate at HashiCorp. I've done some stuff in my career. I've been around the industry about 20 years. I've been saying for about 3 months now that I'm just on the final draft of my book, Building Microservices in Go, which will be released maybe this month, but who knows? And I want to talk to you about Nomad. So, who uses Nomad? I'm going to start with the low-hand question. Why? What's wrong with you people? Nomad's awesome. Who at least has heard of Nomad? Okay, so everybody put their hand up. Why are you not using Nomad? What I'm going to talk about is I'm going to do a quick run through of some of the features of Nomad, but I don't feel that any presentation is really complete unless you have a high-risk demo. So I have a high-risk demo for you. So what we're going to be doing is we're going to be running a multi-cloud Nomad setup. So we're going to be running a cluster in both Amazon and in Google Cloud. And what we're going to do is we're going to kill one of the clouds, and the demo is going to continue to work. And if it doesn't, it'll probably either be Google or Amazon's fault, certainly not mine. But anyway, so a quick overview. So HashiCorp, we're in our 5th year now. We've gone from the 2 original founders, Mitchell and Armon, and we're now 104 people. By the time we have our internal conference in July, we're going to be, I think, 121 people. And that's quite incredible, considering I joined the company like 4 months ago, and I think we've increased by about 30. So it's definitely a growing company, and it's really fortunate that we are growing because it means we can put more energy and more effort into our open source products. So what's our mission? And our mission's always been that we kind of want to be able to just make everybody's life easy. We want to be able to allow you to provision your infrastructure, to run your applications, to keep them secure. And there's a few people who are using our stuff, and I'll skip over, but this is the ethos. So this is the tile of HashiCorp. And it's centered around these 6 products, where we have Vagrant, which was our first product, and Packer, which was our second, Terraform, which has been around for a few years now, and Console also, which was certainly one of the first of the HashiCorp's, what I would think is like the new generation of products after Vagrant that I had personal exposure to. And this one that probably 3/4 of you have never heard of, and the 3/4 that have, for some unknown reason, are not using Nomad. So Nomad is a scheduler. And, well, they're self-explanatory. Schedulers are all about mapping work to resources. And if you think about the history of those, then it's nothing new. I mean, your computer has been running a CPU scheduler forever, ever, because you have more processors than you do cores. And in terms of what that looks like in the world, you have CPU schedulers, so they're dealing with the threads and your physical cores. And then you have things like EC2, which is managing hypervisors and virtual machines, Hadoop, MapReduce jobs, and then cluster schedulers. So you have things like Mesos, Kubernetes, Nomad. And these are kind of all about that higher resource utilization. So we're not managing the underlying infrastructure. We're not managing the boxes. We're managing about being able to run our applications and being able to do it in a way that's quite seamless. And it's about decoupling the action of deployment away from the physical infrastructure to some extent. So for higher utilization, we've got techniques like bin packing, and bin packing is all about trying to squeeze as much stuff into your compute resource as you can. And you want to try and avoid things like oversubscription. You don't want job queuing. But you also want to be able to decouple the actual work itself from the resources. So you want nice abstractions and API contracts and standards. And then qualities of service. So this is not a new thing. Google released Kubernetes. Before Kubernetes, there was Borg. Amazon have been doing stuff with Elastic Beanstalk, and then ECS. You got Mesos, which was what I would actually say is the very, very first stable scheduler. And when I'm talking about history, I'm talking like a couple of years back. I mean, it's amazing how fast everything has moved in that couple of years. And Twitter there, who sort of put a lot of prominence into Mesos. So what about Nomad? So Nomad it's an integrated scheduler and cluster manager. It's distributed, it uses shared state, and it's optimistically concurrent. So it's agent-based. So what that means is you have the concept of a server and you have a concept of a client. The server doesn't run jobs, only the client nodes do. And the big thing for me with Nomad is that you have no dependencies. It's a single binary. So some of the things you can do with Nomad, you've got the capability of multi-data center, so thinking about your availability zones, multi-region. Now this is something maybe not a lot of people use, but I'm going to come on to why you might be interested in multi-region in a little bit. It's highly performant, highly available. You don't just need to run Docker containers. So there's a variety of workloads that Nomad can deal with, from application binaries to virtual machines. And like all of our products, it works perfectly fine standalone, but it also, we try to make everything seamlessly integration. If you use the full suite, then everything works nicely. If you don't, it still works nicely. So the fundamentals on how Nomad works and how it attempts to sort of be concurrent and available is that we use this concept around the raft. So we have a single server leader. So you'll always have a quorum of servers. So you'll have 3 or 5. We don't really recommend you go over 7 because we don't think you're sort of getting the cost benefit for replication just isn't there. But actually, it's only the leader that makes the decisions around scheduling. The servers are there as backup in case the leader disappears, and then we need to do the whole leadership election thing again. But they will just forward requests to the leader, which is actually the main decision maker. It's the thing that does all of the writing to the state. The state is then replicated out to the servers. And in terms of multi-region, we use a very, very similar concept, but what we also use is a slightly less concurrent gossip-based protocol over WAN, which allows you to connect clusters together. So again, the leader in region A cannot make decisions over the nodes which are actually running the jobs in region B. All it'll do is forward the request to the leader in region B over the gossip. And that way you have this incredible high availability and redundancy. So it's an Omega class scheduler. It's based on the kind of the predecessors to Borg. It's similar concepts to Kubernetes. You have this pluggable logic, and it has the internal state. And as we've already mentioned, multi-region, multi-data center. But in terms of the operating system support, we build all of our tooling in Go. So actually, pretty much anything we can compile Go in, you can run any of the HashiCorp's tools on. So it's capable to run it on Windows, Macintosh, Linux, anything you like. And the servers are not limited. So you could potentially have a leader which is running on Windows, and you could have a server which is running on Linux. As long as they're connected to the same VPC, close area network, it's all fine. So in terms of the containerized workflow, we deal with Docker, we've got Rocket. We're building in functionality to deal with Windows Server containers, virtualization, QEMU, KVM. We're looking again at expanding that out, Zen, Hyper-V, and standalone, which is one of the interesting features for me. You can use Java, you can run static binaries. We're going to have C# support because a lot of the Windows community wants that. And standalone, when I start talking about the parameterized jobs, I think that'll make a little bit more sense. So like a lot of schedulers, you've got the capability to be able to do client fingerprinting. So you can fingerprint things based on like the operating system, the actual hardware, the apps. So you can target your job at exactly the right client node. And I'm going a little bit quick because I don't want to leave time so you can laugh at me when my demo goes wrong, which it isn't. So the job configuration. So when we kind of built the job configuration, we were looking at something, we wanted it to be sort of very declarative. So you have to have that medium between human readable and machine readable. It needed to understand things like the driver, so whether you're going to be using Docker or Rocket or a single binary, and it needs to be able to cater for the resource needs, such as memory, CPU, or physical hardware constraints. And it looks like that, which is fairly straightforward. So at the heart of it, you have a job, and a job, you declare which data centers this job can potentially run in. And data centers, again, if you're thinking Amazon, is kind of your availability zones. It's not Google or AWS. And then the task declaration, which is kind of like the all-encapsulating thing, which declares things like the driver. You can specify Docker here. We're then specifying a container image, and we can set out some of the various constraints, such as the resources. And the thing is that an app, which is a group, can contain multiple tasks. And if you declare multiple tasks within a group, when you schedule that job, you can make sure that they stick together. So if you have application instances which need to be running on the same physical machine, you can kind of group those together, and you can tell it to only deploy those in a group to the same nodes. And again, just a quick look at the constraints. So one of the things that we have there is, and if anybody's familiar with Terraform, there's the interpolation syntax, which allows you to use kind of built-in variables and some very, very simplistic sort of logic constructs. And these are built into the Nomad job definition as well. And then I suppose the service part, because we need to be able to register our services for service discovery. And if you use Nomad with Console, hardly surprisingly, they work really, really well together. So Nomad will register the job in the service discovery catalog at Console. It'll also make sure that the checks and the various other things are up to date and are running away. And if you want to do something a little bit more complicated, you can, again, go a little bit more heavy on the interpolation syntax. You can use things like very basic templating. But this is an interesting feature. So one of the things that I actually quite like about Nomad is the concept of a parameterized job. And a parameterized job is kind of one of those ad hoc workflows. So you You don't want to be kind of running a job, an instance continually, but every now and again you need to spin up an instance, do some work, and then exit. And Nomad's got the capability of defining things as parameterized jobs, which allows you to do that. So when you start the job, it will register it with the scheduler, but it doesn't actually trigger it until you call the job dispatch, which you can do with a piece of JSON. So if you're thinking around your workflows, this could be something like this example, which is encoding video. It could be something which is responding to events. So whilst this example is showing the command line, we do have a fully featured API which you can use to interact with the system in. And the bit that I'm most excited about, or fearful, is multi-cloud. So, and I asked myself this, right? But why multi-cloud? And I think, would the majority of people ever really want to be running half of their workload in AWS and half of their workload in Google Cloud for a high availability perspective? Well, probably some people would, and it'd be probably quite a small proportion. But you can achieve redundancy around cloud resiliency. So if one of the cloud providers does actually go down, your cluster doesn't. Burstable workload is an interesting option as well. And what we see is that there's still quite a lot of people who are in that cloud migration phase. So you may still have quite a large amount of physical tin, you may be running VMs, or you may be running a lot of stuff on-prem, but you need the capability to burst that sort of workload under high demands, things like Black Friday advertising campaigns. And multi-cloud can facilitate that. And cloud migration as well. So if you are a Google Cloud customer and you want to move to AWS, or you're an AWS customer and you want to move to Google Cloud, then using the multi-cloud features of Nomad can actually help you to do that transition because it kind of the seamless integration. And I think most importantly for me is just, well, because I can, and it'll maybe make an interesting demo. So what are we going to do? So this is our reference architecture, and we're going to have a console and a Nomad cluster running in Google. We're going to have a console and a Nomad cluster running in AWS. Now, to be able to sort of load balance the applications inside of each of the cluster, you've still got to have your sort of localized application load balancer, and we're going to have one of those in each of the cloud platforms. But in addition to that, we need to have a load balancer which is sitting in front of both of the cloud platforms that we can kind of load balance against. And we're going to use Fastly in this demo because they've got a pretty nice API that I could spin some stuff up with Terraform. But you could use things like Cloudflare. You can actually use Route 53 or Google's load balancing. It depends what your aim is, whether it is that sort of ultimate high availability or whether it's redundancy. And while I take a breath, scheduling. So we're going to look at how this sort of works in a little example of scheduling some of the containers into this multi-cloud environment. And we kind of discussed some of the ways that scheduling works. So one of the things that I didn't talk about is system jobs. And system jobs are quite important because a system job is something which will be scheduled on every single node. So these are things like your metrics collection. In the example I'll show you, I'm running statsd, the Datadog statsd collector, but I'm also running our internal sort of the application load balancing for the nodes, of which we use an application called Fabio, but there's all sorts of amazing other tools that you can use. And it's as simple as that. Nomad plan pointed at your file, and Nomad will first do a dry run. So it'll tell you if it is actually possible to execute your job. And it'll form a plan of where those applications are going to be allocated to. If in the instance that it can't, it'll tell you before you actually execute the job. So that's a useful early warning system. And then to run the job, very, very simple. Just Nomad run. But what about if we need to run it in a different region? Well, I don't need to go and log into the other region's servers. I just need to specify the region in the Nomad run command. Because of that gossip protocol, the request will be forwarded to the correct cluster. And then just, again, some more information. We can see diagnostics, what's actually happening with that job. So I had everything, like all my tabs, everything logged in, and my laptop crashed. So let's see. So what I'm going to do is, I've got a Bastion host which is running in AWS, which I'm going to use to interact with the clusters. The clusters are all locked down in terms of the way that the security groups and the VPC, so you can't actually access the APIs from external. Now that's by design, not by, it's by configuration, so it is completely configurable to yourselves. You can choose to do that, but we recommend you lock it down. Standing and typing is just the biggest challenge in the world. So I'll log into that Bastion host. That's a good start. So what I need to do is, because I'm not actually this server is not part of the cluster, I just need to point my Nomad. So I'm going to get the internal IP address eventually of my one of the instances in the Nomad cluster. It doesn't matter because everything will be forwarded onto the leader. And I'm just going to set the environment variable so I can just use the command line tool. Cool. So that's all working. So now what you can see here is you can see the members of the Nomad cluster, and what you're seeing is both of the regions. Now, one of the things that I didn't mention around the configuration of this is that there is no configuration. So we use AWS or Google or Azure metadata to automatically bootstrap both the console cluster and the Nomad cluster. So the console cluster automatically bootstraps, automatically joins itself into a cluster, and multiple regions, and then the Nomad cluster uses console to identify the other Nomad agents, and again can automatically bootstrap itself. So I've got some jobs here. If I take a quick look at one of them, and I'll show you that in a bit more detail. So again, the concepts we were explaining earlier, so we're going to say this job can run in multiple data centers. We're going to configure the update intervals. We're going to set up a group, and we're also going to set a constraint that we want the instance of this to only be running on distinct hosts. And if it crashes, we set up some restart stuff. But then we've got two applications. One is a publisher, which is attaching to the event bus. And the event bus, again, is sitting outside of Amazon and outside of Google. So it's cloud agnostic. It's using NATS Cloud for the example. We can configure the port map and define how we want that. So that's kind of in the same way as you would do with your Docker ports, and set up some environment variables. So again, the interpolation syntax. So my statsd connection, I want to pass the name of the cluster node to the application so that the Docker container can talk back to statsd without actually having to link it directly. Defining some of my resources, and then exactly the same thing with the other tasks. So we have the service definition, which defines the health check, and again, there's another task. So if I run that, nomad run, that was as easy as that. And then if I do nomad status, what do I call it, events, I can see the status and that it's been scheduled, and I've got the allocation information, which again I can dive into, if I could remember what the command is. To go into further detail. But we also need to schedule these jobs running on Google. So I can do exactly the same thing. I can run, but this time I'm going to specify region equals GCP. And again, if I do status on that, that will have scheduled that job on the Google region. And that's running there. So now, if I run my test application and I'm getting 200 OKs, so that's a bonus. In a little while, we should see some stuff coming in Fastly. What I wanted to show you, if I could have logged into Datadog, was a chart. Let me just give it that one quick go. That isn't going to work. Show you a chart which would actually show the distribution. So you can actually see the number of hits, and then you can see that half of them are hitting GCP and half of them are hitting AWS, because we've got that sort of configuration. But if you look at the little top thing there, 200 OK, and if you're really astute, you can kind of see that half of them are hitting Google. But what about a total outage? So if I go to my auto-scaling groups, and maybe I'll just delete it. And maybe I'll just delete this one as well. So I'll get rid of the servers, and I'll get rid of the nodes. And we're still hitting 200 OK. We might get one or two 500s as the load balancer is marking the actual entire cloud as unhealthy, but that'll just continue to tick away quite merrily once that deletes. So while we're waiting for that to delete, I will continue. So what about scale? So we've tested Nomad at pretty big scale. So we've run thousands of jobs, we've run thousands of tasks per jobs, and we've run 5,000 hosts on Google Cloud. And we ran 1 million containers on those 1,000 hosts. And this is what it looks like in terms of the time it took to schedule those 1 million containers. It scheduled in under 5 minutes, which is fairly impressive. And you ask yourself, well, like, who needs to schedule 1 million containers? Well, yeah, Bill Gates. But Citadel out in the US are a big hedge fund. They're running 18,000 cores, and they're running 2,000 containers a second. So there are people running really big loads on Nomad. And that is still deleting, but we're still getting 200s there. So whilst I offer you Q&A, I will try and log into Datadog. Any questions? Are you disappointed that the kind of the demo only semi-failed and not the bit you were hoping would fail? Well, I'm on a really short deadline today, but I will be around for about, oh, sorry, question. Yeah. Oh, more questions, all the questions.
It's not about Nomad specifically, but about HashiCorp for that. So especially the specification. So you are using JSON and Terraform specification defined parsing. So why don't you just use YAML?
So the question was, why don't we just use YAML instead of HCL, the HashiCorp configuration language? So the reason that we don't use YAML is because we don't think because of the white space indentation, it gives us much in the way of a user experience that you get from having things like parentheses and braces. So the HashiCorp configuration language under the hood can actually be boiled down to JSON for interpretation, and the two do directly interoperate. But the feeling was that we needed that sort of real bridge between the machine readability and the human readability. And YAML doesn't quite get there. So YAML's quite human readable, but when you end up with a lot of nested structures and very, very sort of lengthy documents, it can be quite overwhelming. Also, in terms of the parsers for YAML, they can be somewhat limited in the response that they give back to the user from a user experience. So is that subject to change? Probably not, I would think. I think we're sort of settled on HCL for the near future. Is that?
Yeah, thanks, but I mean, with JSON, it's the same thing. I mean, you end up, by the end, you will find yourself right in some...
So I think JSON goes onto the other side of the scale. So JSON is very, very machine readable. It's very easy to parse, very, very quick and efficient to parse. But from a human readable side, it's maybe a little bit sort of further away. So literally HCL kind of sits slap in the middle between JSON and YAML.
All right, thanks.
Okay. Question over. Oh.
Ça sera la dernière question.
Hi. I see that in the job definitions you map the resources that the job is supposed to consume. How do you map this to the actual resources? Like on a AWS, it's a kind of magic to do the math between the instance type and how much CPU you get.
So Nomad isn't aware of which platform it's running on unless you specifically tell it. So you can do that by either setting metadata, but more often than not, people will use the naming conventions around the data centers or the regions to be able to do that. So there's the nodes themselves don't know that they're running in AWS or that they're running in Google unless you explicitly tell them. And if you explicitly tell them, then you can use that as a condition inside the conditional stanza of the job definition. Oh.
Merci.
Thank you. It's still working, by the way.